Hello everyone, today we're gonna be speedrunning a wall in Revit. So we're gonna make this wall from scratch, just using this AutoCAD drawing. We're gonna use Revit, Sofistik, and Civil 3D. And here you can see the profile view of the wall. It has a few sections, as we're gonna see. These are the sections. So we have like a straight part and a sloped part. Here it's straight. The length of the... Now what is the difference between this one and this one? Is there a difference? Why is that different? 2730, 2730. This is a straight part here. It says it's the same length. Let's check. Okay. So everything is the same. I don't know why it's different. Here it's different. 4.4 is not included here. Let's see if this is sloped. This looks weird. Is this sloped? No, no delta Y. Okay, let's begin. First I'm gonna be starting a Revit project. File, new project. Template Revit. Back to Civil 3D. Here I have a template with all the styles and the coordinate system already in place. Paste to original coordinates. Now zoom, extends, delete this, zoom, extends. Okay, now I'm gonna save this. RW16, RW16. Okay, we saved it. Now we're gonna insert it in Revit. Link CAD. By shared coordinates meters, okay. Okay. Imported categories, show imported categories. Let's zoom, extends. Okay. Let's check that the coordinates are more or less what we expect. Yeah, it's more or less what we expect. Go back to Civil. Now this is like a road sign foundation that's integrated into the wall. We're not gonna be modeling it here. So basically our wall is gonna be this part and this part. So we're gonna have two axes. So this is the insertion line for the wall. Let's check this in the section. This looks weird. It says 27 centimeters. We're not seeing the line here. Like we should see another line here, this line, from this point. Okay, we're not seeing it, doesn't matter. Okay, alignment from objects. This. The direction is correct. Okay. You see the little arrow for direction. You can later reverse it. Now 16.1, RW 16.1. Do not add curves between tangents. This is important. This basically creates curves where two straight lines meet, which we don't want here. Don't erase. Okay. Delete this. Create another axis. Another alignment from objects. Enter. The direction again is correct. 16.2. This, okay. Now profile view, create profile view, 16, create profile view. Now we're gonna be moving it here. Let's first change the elevations by hand. 25 to 40. See that it ends exactly the right place. There's a little bit of a problem here. You can see our alignment is a little bit longer than the wall. We're gonna ignore that though. Okay. Let's explode this block. Explode. We're gonna need to create a profile out of this line and a feature line, and from this line here. So I have a Lisp command for that to create a profile from that. It's getting hot here. Okay. PFP. Well, I'll show the name of it. You can search it online or ask me. So profile toolbox, PFP. Select the polyline, profile view. Now it's created. Select the profile, RW16, 1, top. Okay. Now PFP again. Select this one. It says it's not a polyline, 2D polyline. Okay. Let's explode this. Now it's a line. Okay. So now polyline. Okay. PFP. Okay, change its name. RW16, 1, bottom. Okay, and now we're gonna have a main axis where we insert our superstructure in Sofistik. So let's do it on the 35 line. want it to be horizontal for certain purposes. Okay, again PFP. I can't explain everything because I am trying to make it fast. Okay, now select this, delete. Again, give it a name, RW16.1 main. Now feature lines from alignments, select, give it a name, the same name, RW16.1 main. Make sure it's on none, the site is on none. Otherwise it's gonna create problems. Okay, again the same thing. Again the naming, RW16.1 top. This is the boring part. Again the same thing. Bottom, RW16.1 bottom. Set is none, okay. And now the same thing for this part of the wall. Let's first connect our top line. Hopefully this will join. Did it join? Yes. Let's see. Join. Okay, and create a profile view for it. Create profile view. Create profile view. Elevations again. We already have a 35 line. It should move. Where should it move? Over here. Let's see that the length of this one is correct. No, I moved it into the wrong place. Excuse me. Should be moved over here. Again, I keep getting confused there. Wait a second, let's do it correctly. This needs to be moved here. Now it's correct. Let's see what the difference is here. 1 centimeter, doesn't matter. Okay. Okay, and now the same operation we did before. Polyline, polyline, wait a second. Polyline, profile view. Give it a name. You have to change the name from my profile to some other name. RW16.2 top. And now the bottom is stepped, so actually we're gonna create a parameter in our family to have this no, excuse me. So this part is sloped and this part is stepped. So here there's a step and here it's sloped. So what we're going to do for the bottom is this. We're going to create a line which is, wait a second, is too small. Line. Now we want to make it not vertical, so something like this. We're gonna join this. Some reason it didn't join. Let's try. No. See if it joins now. Join. Okay. So PFP. Select this. Profile view. Okay. Profile. RW162 button. Okay. Again, the main axis. Is this not a polyline? It's a polyline. Why is it not creating? PFP, profile view, profile view. Okay, RW16 to main. To main. Copy. Okay. Feature lines from alignment. RW16 to. The name is this one. Okay. Okay, again. Bottom. Bottom. Top. Top. Okay. So this part of the Civil 3D stuff should be over. There might be a problem with the importing it into Revit, but let's see. RW16 access 0.0.25. Okay, save. We're also gonna be modeling these placements. So these expansion joints. So we're gonna need this distance here, which is given to us, and I could do it using points and exporting the point coordinates and extracting the station along the axis or alignment, but instead of that, this is so few placements, I'm just gonna be doing it by hand, I think. Save you the time, save some time on that. So now, Sofistik Bridge access, import, RW16 access, Now we're gonna have to do all of this, but first let's see that the lengths are correct. We need to, what I'm checking for is if all the lengths are the same. They need to be the same also as the alignment. Sometimes it doesn't port over correctly. You see the bottom is only 10 meters in RW16.2. What's the problem with the bottom? First of all, let me show. This is a speed run, I'm not gonna show it. I'm gonna first resolve it here. So the bottom, this is the bottom profile. Okay, what we're gonna do is select our bottom. You see the length here is 24.4 and it was the wrong isolate. It was the wrong length in Revit. So this is correct. We're gonna explode. Now we're gonna feature line from objects. Enter the name RW16.2 bottom. Wait a second. Okay. Faster, let's do it faster. Save, yes. Faster. Let's see if it's correct. Yes, it's correct. Why is it only 24 and these are 29? Let me see what is going on here. I might have made a mistake. Okay, this is not correct. So, this is live, this is not edited. So, line. This one. Do a little vertical line, 0.01. Join. Yeah, a lot of times it doesn't want to join. No, join. Okay, join. Now we do the same PFP. And we already know that probably it's not gonna import it correctly, so feature lines from alignment. So we're gonna explode it preemptively in my profile, okay. We didn't change its name, but that doesn't matter. Okay, isolate. Explode. Feature lines from objects. Enter name RW16.2 bottom. Okay. Now export again. these feature lines. Okay, I think it's this one, short side. Okay. See that it's correct here. Looks correct. Import now every one of them. Short side. And again. Let's see it in 3D. Looks correct. Everything is imported. Okay. Now the point with this is that this this vertical kinda jump is gonna be hidden by our expansion joints. So we're gonna model the expansion joints, and that's gonna hide it. Remove all these extra placements. It really hurts the eyes. Remove. And again. Okay. Now we do the same for the other part of the wall. Shared side, horizontal projection. Okay. Remove the extra placement. Okay. Now we're gonna make our cross-section family. Let me check that I'm recording. Yes, I'm recording. Okay. Unisolate. Unisolate. Okay. And now we have our section, so we need to keep in mind everything we need to model here. Okay. It's not that complicated. Okay. Okay. We're gonna be making 3 sections for the wall, for the leg, and for the blending concrete, but we're gonna put it everything in one family in order to make it more usable. We are gonna do these things parametrically, the straight part length, the slope, everything. Let's begin. File, new family, generic model, adaptive. Let me save it for good measures. Save it for good measures. Families. Wall. RW16 wall. Okay. Begin by making the placement points. So our wall can only have one adaptive point and shape handle points. So one placement point and as many shape handle points as we want. Now we're going to create 2 shape handle points for the top and the bottom, and one placement point. Make sure you're doing the section on the right or the left, like the section should be here, drawn like this. I'm gonna use the 3D because it's much easier for me. Okay. I'll do a little bit without talking because this is understandable. I'm gonna give this an offset if we ever need it. Offset vertical. And now a rotation, if we need to flip it, flip the section. R1. And now always. You can speed this up even more by using hotkeys, which I'm not going to be setting right now. Offset horizontal. Okay. Okay, now we're gonna need two shape handle points for the bottom and the top. This is gonna be a shape handle point. And this shape handle point. Now we have to give it a name. Name bottom. This is top. Top. Okay. Create a reference line to attach to, change the units because I cannot work in millimeters. 3000, let's say. There are other ways of doing it, but this is very convenient. Reference line. Now we host 2 points. Now host point by intersection. Select the plane of our placement point. Host point by intersection. There we have the top and the bottom. Now we're gonna model the leg. So I need to think right now. This is the placement point, so the leg is gonna be in that direction. Not that it matters, but yeah, the long leg is gonna be in that direction. Okay. So this direction, okay. Long leg width. We have the thickness of the bottom of the wall as so wall bottom thickness. Let's say for now it's 40 centimeters. So x2. Negative this. This is x1. Excuse me, this is here. This is gonna be on x2. X2. Now we have short leg width. Okay. Let's say it's again 40 centimeters. And x2 is gonna be this one, okay. We have this point, which is gonna be x3. That's the thickness of the short leg. Okay, short leg thickness. Okay, and now we need, from this point, we need to go down. Let's go back to our drawing. We need to go down, first of all, by the short leg thickness, and then go up from that, the long leg thickness. So let's do that. This is, yeah, okay, from here. From here. This is x3. Now, and we're almost done with our leg. Goes pretty fast. Okay, and that is long leg thickness. Okay. Now Sofistik doesn't allow us to use visibility parameters in its superstructure command. So we have to use a length variable, and according to that hide whatever section we want to hide. So we're gonna give it a visibility leg. Soon you're gonna see. And now the blind in concrete, let's see that everything is in the right place. Let's change the parameters a little bit. 50, 60. See that everything looks correct. Okay. Wait a second. Wall, long leg thickness, let's say this is 30. Okay. So now the blind in concrete. For us it's always the same measurements. It's always 5 centimeters outside the element and 5 centimeters below the element. So I'm not gonna be giving it a parameter. This thing works much better in sub-assembly composer. This wasn't really made for that. Let's see. 5 centimeters. You can speed this up with hotkeys. But this way you can see exactly what I'm doing. Okay. Now we create the section. Now I'm using the spline through points command. Make sure you select only 2 points at a time to create a straight line. The other commands here are not that useful, let's say. Okay. Now this has a visibility parameter. Blinding. Okay. Now let's create the top of our wall. Let's see how. So we have this point here. So we have a parameter for the top wall thickness, and the parameter for the bottom wall thickness, and we need to go inside by the difference between them. Okay. Let me hide this. Always. Did I do it wrong? Something looks wrong to me, I don't know. Yeah, I did something wrong. I did do something wrong. I need to fix a parameter. So the insertion point is this point, and I did it as if it's this point. So a few things we need to do. Let me correct this. Okay, this is more of a problem than I thought. Okay, I'm gonna delete it. That's what happens when you do it live. But little things like that can confuse you, and it's really... dissolve. Let's delete this. Okay. Wall top thickness. So 30, and X4 needs to be wall bottom thickness minus wall top thickness. Okay. If this was a real speed run, I would have to reset, but yeah, it's a speed run, but yeah. Long leg width. Long leg width. from this, we need to go outside by this is x1. So x1 is actually gonna be all top thickness. Wait a second, what did I do here? This is x3. x3 is longer thickness. Wait a second. Ah no, it was correct before. You start doubting yourself. Everything kinda crumbles. Okay. And this one, okay. And now short leg thickness, we set it x3, right? Create it again. Wait a second, again I made a mistake. This is short leg width, which is x2. This needs to go outside by x2. I'm trying to rush it and it just creates more problems than it solves. That's the problem. Short leg thickness. What was that? X3? X3. What did I do wrong now? I deleted, inadvertently deleted this. Is there a point here? No. Deleted this point. It's beginning to become a clown show, I'm sorry. A clown show. And what was that? Extreme. Like one oversight in the understanding of the how it's constructed is like very. We could have solved it using a horizontal offset, but you know, long leg thickness. Okay. Now it's correct, I think. Okay. Let's see that it's horizontal. Visibility, leg. Now the blinding concrete. hope that the wall is gonna go faster. Now we have this. Okay. Meant to do isolate. So let's hide this. Wait a second, is this? No, it's this point. Excuse me. Now a parameter for the straight length of the wall. Straight length 100. Excuse me. So we don't need this point? No, we don't need this point. Okay. Wasting time now. Again, if you overthink it, you might get it right the first time, but it will just end up costing you a lot of time in the long run, because you overthink and try and imagine the section, and it just creates more problems than it solves. So sometimes it's better to just do it by brute force, you know. Make sure it's all selected. How many lines we have here? 5. 1, 2, 3, 4, 5. Okay. Now the visibility is set into wall. Okay. Okay. Now create a visibility length parameter for visibility. Now 0 is gonna be blind in concrete. For visibility equals 0. Now the leg is gonna be positive. Now someone who doesn't know what you did might have a hard time, but if you're doing it for yourself, or you're in an office and people learn what you did, and okay, one time they're not gonna get it, but another time they are gonna get it. First of all, see that everything is working. Put it on 1. Now you wanna check sometimes, I'm not gonna do it, but check. Okay, you see, maybe we have a problem. Why did it do that? Why did it not create what we expect? Is this correct? Well, let's hope that it works in Revit. Ah, we didn't save our project. What project is this? This is an older version of the wall. Okay. Now we need the placements. Let's return. The placement looks exactly at the break-in of the line here. So this is too loud for me. So we're just gonna create it manually. Add placement. Let's see what station is this. 6.543. Now check the orientation of this. So we need basically to rotate it. Let's see what angle. .873. Placements, rotate this. 12.873. What did I just say? 12.873. 873. This is a good sign, okay. And now we turn to see what parameters we need. What section is this? Section 5.5. So this is 27, this is 16, 16, 13. Okay, I can't remember everything, but Sofistik Bridge, superstructure, create. I didn't load the family. Did I load the family? No. Superstructure, create. Okay, 0, 0. Long leg thickness is 30 centimeters. Short leg thickness is 60, I think. Wall bottom thickness is 60. Wall straight length is 1. Top thickness 0.27. Bottom is this. Top. Yeah, here we select the axis. So axis reference, you see the shape little points we created, we gave them a name, and we attach to the axis here, and we can choose from a list of axes. Okay. Now return to civil wall long leg width. Let's see. I'm not gonna remember that. Distance 2.65 and this is 25. Okay. 2.65 short leg width 0.25. Let me think if I'm missing something before I start this. So here I'm creating actually I did something wrong. I should have done a superstructure repeater. I should have done a repeater. Let's see. Let's cancel to save time. Otherwise we're gonna have to duplicate from this section to this section. So let's create a repeater. It's gonna save time eventually. Again, this phenomena. Okay. Wall bottom thickness 0.6. Long leg width 2.65. Long leg thickness. Short leg thickness 0.6. Top this. Now gap at start 0, gap between 0.02, horizontal projection. It's gonna create basically two superstructures, one for each segment. Let's see if we miss something. Maybe 30. Now this is important. Placement rotation, we have to say, we have to specify either shear mapping or void cut, because we want it to be angled along our, you know, the placement. We want it to be cut exactly like that. Okay, let's see everything else is okay. WL 0.02. Let's see, the length of the straight section is 1 meter, right? 1 meter, yes. 27 centimeters. Top wall thickness 27 centimeters. Okay. Now I think it's alright. Okay. Now why is it doing that? Why is it doing that? Maybe we should have done it separately. I I thought it would work, but I think I understand the problem, but how we're gonna resolve it? I don't think we can resolve it. I think we have to delete it. And it's, we need to put 180 degrees. Okay. Superstructure, create. This is the wrong axis. No, 180 degrees. Okay, 180. This is the bottom. Okay, 27. Minus 0.01. That's not the projection. Shear mapping. P13. Okay, let's see what it's doing. Yeah, again, it's I don't know why it's doing that. Really don't know. I think I'll try something. I think I'll try and create another placement a centimeter outside that. 6.433. Let's see what angle it creates it at. I changed the axis and it's updating everything. Let me quickly create settings. Don't update dependent elements. I just don't understand why it's creating this on this angle. do like this. Every complexity that you introduce, like this kind of break-in zone, like that. If it's complicated like that, it's gonna create problems and you have to solve them. So, like, you know what you do, it's a good thing. So, let's duplicate. Now for this segment, this is relatively simple. We just changed the visibility. We did the duplicate superstructure, change the visibility to 0. And so this is blind in concrete. So we changed the naming of the family and the material. We had OK. This is OK. Now we have the blind in concrete. Duplicate. And now we change it to a negative number. Hit OK. Now we have the first segment of our wall, superstructure, duplicate. Now we're just gonna move this one. 0, 1 to the end. Okay. Duplicate. And we're moving along here. Once you have all the components, it's not that difficult. So remember that we model the families, right? So it takes some time. But this is of course much faster like this than to actually create walls in Revit in some other fashion. This goes much faster. Now we need the placements for this segment. So let me see the placements. Let's do it section by section. So this section is 481, which is the same section that we did for this one. Why does this say 262.3? What is going on here? Something is going on. Okay, but we say 481. We need a placement at 481. Let's see that it's the same as our plan view. Now the lines are jumping, so we can't tell here. Let's go back. Create a profile. Create this profile. Now I want to create the points, alignments, profile geometry points, select alignment. We have to go here. Let's see. Yeah, this is more or less correct. It's a little bit off. So now you could do it in Excel, but I'm gonna do it in another way. I'm gonna check manually. I wanna check this manually. Well, this is gonna be how to check manually. Let's do it like this one. 481. So our drawing should be correct. It's more or less there. You see that this problem with the imports where it's shifting. So you don't really know where it is, but okay, I'm gonna call it. So we need basically the same section as this, only here. Let's do it. Now, if you could save presets here, that would be very nice. We need the 180 degrees probably. Long leg width 265, short leg, long leg thickness. For visibility, short leg thickness. And 6. 25. 6. 7. Did we do everything correctly? I think we did. It takes time to process, that's why I'm trying to save time somewhere else. Now we could export this to a DWG 3D Solids and check whether it's in the right place, but I'm not gonna do it now. I do want to check an elevation, one elevation at least. See that we're not like missing something big. This is, why are my elevations like this? I think I have a problem. No, this is, I'm getting not the elevation I expect. I'm getting like an elevation from the internal origin, not from the project base point, elevation base. Let's see, 31.1. Let's see that this is 31.1. Distance. You see, this is the bottom. I did the wrong bottom. There's an easy fix for that. think if we just move this by 60 centimeters. That should align, no? It's not aligning. Why is it not aligning? I see. There is a fix though. Let's fix it. Since we only did one section, so it's not gonna be. That's why I wanna check, you know. Now, if you do it by some sort of manual method, this will take you a long time to correct a mistake. If you do it like that, it can be a pretty quick fix. Top, final. Feature lines. And this is what didn't import, right? So it's bottom, not top. Bottom. 'Let's import the correct one. Delete this. Again, it's the wrong name, doesn't matter. Since we checked, we caught the problem in time. We caught the problem in time. Okay. 32.3. Let's see, we don't have a problem here. 32.3. And isolate. $31.7 plus 6, 32.3. And this is should be 31.7, right? $31.7. Okay. So now we're getting towards the end, so let's continue. Not going as fast as I had hoped, but it's fast enough, I think. I haven't checked the timer. I'm gonna see how much we did. How much we did here. Okay. Duplicate. Now this is why we did all three. This is another reason we did all three sections in one family, so we can use the duplicate command. Now we're gonna need another placement for the how many more placements we need? We need this one. Okay, and another one. Let me see. You can do it with Excel, export the points, and this is how I usually do it when there are a few sections, but now where did I put that little line? Was it here? Ah, this is it. No, again, I'm doing it wrong. Here and here. 14.82 is another placement. 14.82. And another placement here. $21.236. 21.236. Okay. Now this section is 3.3. 3.3. What is the difference? This is 50 centimeters, and the long leg is shorter apparently. 225. Here it was 265, right? 225. This is still 27 centimeters. Yes. Okay, so we just duplicate, move it to this placement, -0.01. This is creating our it's creating our expansion joints. Now long leg width is 2.25, right? Let me check. 2.25. And the thicknesses are 50. 0.5, 0.5, and the straight length is 110 instead of 1.1. Let me see if there isn't another thing. This is 30 centimeters. Okay. I think everything else is alright. Just duplicate. That's all we do. Change a couple of parameters. Like you're not really modeling, right? You're not like performing any repetitive tasks other than changing a few parameters, you know. It's like very simple. The leg, and now the blinding concrete. When we will hide all the excess, it will look much better. And as you can see, there is a segment here. This is the same wall, but it has segmented, probably because there is a discontinuity in the axis. But this is better than how it usually goes. Let's see. Now we have these two segments. I forgot one placement. No, I didn't forget the placement. So these are two different segments. Okay, two, let's see. So it's the same thing. No. 185, 27 and 30, okay. Again, duplicate. $185, 30. 185. The straight leg width might have changed, let's see. Yeah, this is 1 meter. You either double check yourself or you have to go over everything. This is our usual business here. We're getting almost done. I think it's been an hour or something. Duplicate. Let's compare to the plan view. Looks alright. Superstructure duplicate. Check the parameters in section 1.1. This is section 1.1, right? Yeah. I think we don't have a straight. So what has changed? Is it just the height of the wall? So here we don't see any difference. It could be difference in the rebar in the end, but why they did two sections, I don't know. So this saves us time. Let's see what happened there. So you see this didn't work here because I think this is too short. Let's see this weirdness. This is 120 meters for the entire wall. I think the problem is, let's change the straight leg, the strength, length. Maybe that's what's different between the sections? No, this is also 1 meter, the straight length. Let's change this to 0.3. Yeah, you see now it went to the end. So now, obviously the drawing is wrong. So obviously the drawing is wrong. So this is 120. So when this is 120, this is 90 centimeters. So the straight length cannot be a meter. So how are we going to do it? I mean, we have to make a decision. I mean, we're basically, for the video, we're basically done, but I do want to think. This is only 3 centimeters difference. Let's see. You know, I think I'm gonna call the video right here. Like, this is really more for engineering decision. I'm just modeling here. Like how they want to do it exactly. So, but you got the picture. You got the picture. Okay, let's hide everything to have a showcase. So this is our view. You see there were a couple of intricacies here that we solved pretty nicely, I think. Let's change it to realistic. Save the project. Change it to realistic. Let's smooth lines. think it's pretty nice. Okay, let's see the time. How long? 2 hours almost. I think it's alright. I think it's a good good time. What do you think? Let me know. Let me know. Okay, bye bye.